Maximum and minimum points. Today we are going to solve a problem related to maximum and minimum points. So we have a question, the equation of a curve. We have been given the equation of a curve and you have to find an expression for dy over dx, that is gradient of the curve, and you have to show that the x coordinate of the stationary point is 2 under root 3, and then we have to determine the nature of the stationary point. So for part 1, you will be writing equation of the curve as given in our question, and then we will be taking derivative with respect to x. So dy over dx is equal to derivative of equation of the curve, that is 2x plus 24 over x. Now we will differentiate 2x and then we will differentiate 24 over x. Derivative of 2x, in 2x 2 is constant, we will differentiate x, and x with respect to x, derivative of x with respect to x is 1. So answer for the differentiation of 2x will be 2. Then we will differentiating 24 over x. We will move x in the numerator, and when you will move x in the numerator, x will be raised to the power minus 1. We will differentiate 24 x raised to the power minus 1. 24 is coefficient, so we will not be differentiating this. We will be separating 24. We will be differentiating x raised to the power minus 1. As per power rule, shift the power minus 1. Then decrease this minus 1 by 1, that is minus 1 minus 1. So minus 1 will become x raised to the power minus 2. Now this is the derivative of the equation of the curve. So 2 minus 24 over x square, x raised to the power minus 2 will become x raised to the power 2 as it will move in the denominator. Now this is the value of dy over dx that was asked from us. We have solved part number 1. Now in part number 2 you have to find x coordinate of stationary point. Now this is important, and they have given us the x coordinate. We have to prove that x coordinate of stationary point is 2 under root 3. Now coming to the stationary point, at stationary point dy over dx is 0. Now this is a curve. Now this is the point where gradient, which is dy over dx, is 0, and this point is called stationary point. Similarly, this point is called stationary point. Why? Because we have 0 gradient at this point of the curve. So at stationary point, gradient is 0 and gradient is 2 minus 24 over x square, as we have found it here. So equating dy over dx to 0, because we are at stationary point, so gradient must be equal to 0. 24 over x square will come on the left side, x square will move on the right side, it will become 2x square, 2 will move on the left side, 24 over 2 is 12. Rearranging the equation, x square is equal to 12, taking square root on both sides, square of x will be cancelled, under root 12 will be the answer in this case, and upon simplifying this, 12 is basically 2 into 2 into 3. Factors of 12 are 2, 2 and 3. So 2 and 2 is 2 square, and square root will be cancelled. So 2 will come outside of the square root and under root 3 will be left, and 3 will be left inside the under root. So our x coordinate for the stationary point is x is equal to 2 under root 3, that was asked from us. Now the third is the nature of stationary point. Now for nature of stationary point, our next double derivative d2y over dx square is required. That will determine the nature of the stationary point. We have first derivative dy over dx, 2 minus 24 over x square. Differentiate it again. We will differentiate it again on both sides. It will be d2y over dx square, and differentiating the right side, when you will differentiate your constant and you will differentiate 24 over x square, differentiating the constant will give you 0, because derivative of constant is 0. Now differentiating 24 over x square, move x square in the numerator, the power, the sign of this 2, that is in power, will change. It will be minus 2 when it will move in the numerator. We will separate 24, minus sign exists here, minus 24. Now we will take derivative of x minus 2. So we will apply power rule here, shift minus 2, that is here, decrease minus 2 by 1, that will become minus 3 according to power rule. Now this is the derivative. Minus 24 and minus 2 will be 48, x raised to the power minus 3. Move. Now because power is minus here, you can move it in the denominator, so it will become x plus 3. Now we need to find the value of second derivative and you can find that by putting value of x, that was 2 under root 3 here, 2 under root 3, put here 2 under root 3, and upon simplification you will find that its value is greater than 0, greater than 0. If second derivative is greater than 0, then the point is minimum point, that is the nature. So we have minimum point at x is equal to under root 3. Thank you so much.